Right, I'm going to go through 11.3 using trig identities to integrate. So for this you will need the list from 11.1 that you did with Mr. Martin, and you will also need to have all your trig identities with you. So all of these will need a trig identity to be able to do them. You will not be able to just integrate them. So tan squared. We know that sec squared x equals 1 plus tan squared x. So I can rearrange that to tan squared x equals sec squared x minus 1. So to integrate tan squared x, I'm going to integrate sec squared x minus 1 with respect to x. Sec squared x is on the list from 11.1, which is tan x minus 1 integrates to minus x, and we need a plus c because there's no limits here. So we needed that trig identity to do this question. Right, these ones will always be difficult if you try and put everything into your calculator. So I'm going to try, when I go through this, is explain what I'm putting into my calculator and when. So sine squared x, we need a trig identity. Cos 2x is 1 minus 2 sine squared x. So 2 sine squared x is 1 minus cos 2x. So sine squared x is a half of 1 minus cos 2x. So we're doing this between pi over 8 and pi over 12. And I always put the half on the outside because it's just a number and deal with it right at the end. You don't have to do it like that. The textbook doesn't, probably exam solutions doesn't, but that's just the way I do it. I think there's less to deal with. So then I am integrating 1 minus cos 2x with respect to x. So keeping that half there, 1 will go to x, cos goes to sine 2x, but it's a half, so minus a half sine 2x, and we're doing that with between pi over 8 and pi over 12. You can see why I've taken this half out here, because then you're doing a half and a half there and it gets all confusing. It's just, I think it's easier to do it like this. So all I'm doing now is putting the numbers in. So I'm putting pi over 8 in. So 2 times pi over 8 is pi over 4. Putting pi over 12 in, remember it's minus that. Minus a half times sine 2 times pi over 12 is pi over 6. So all I'm going to do, and I know a lot of you would just be tempted to put all that in your calculator, but you're never going to end up with that. So I'm just going to put sine pi over 4 into my calculator. So I've got a half times root 2 over 2. So that's that part. I'm not doing anything with that pi over 12 just yet. I'm going to put sine pi over 6 into my calculator and I get a half. So that is a half times a half. Now I'm going to do this in steps. Still keeping this half here. Pi over 8 minus pi over 12 is pi over 24. I'm then going to put this into my calculator, add that quarter into my calculator. So I'm going to do that all at once. You could do it in a couple of steps, but I can put that in and that in now. and I get plus 1 minus root 2 over 4. And so now you'll notice if I bring that half back into it, I've got pi over 48 plus 1 minus root 2 over 8, like it asks for. So trig identity, things that you could integrate, do it in steps, do the things together, so do those together, work out that, work out that. A little bit like we did when we were doing some of the work in mechanics, work out sine pi over 4 and write that down and see where you go from there. Right, sometimes these are difficult to spot, and this is one of those times, but the more you practice, and even if I only give you so many questions to practice, I really would recommend you practice more, because the more you practice, the more likely you're going to spot them. So I'm seeing sine 3x, cos 3x, and this is a difficult one. If you remember back to year 12, sine 2x equals 2 sine x cos x. So that was something we did last year. You'll have to remember your trig identities from last year. So I can actually say, well, sine 6x equals 2 sine 3x cos 3x. So the only difference there is that if I want, that's 2 of those, so if I just want sine 3x cos 3x, I'm going to half it. So to integrate that, I'm going to integrate a half of sine 6x, which is just a standard integration that you did the other day. Sine integrates 2 minus cos, so that gives you minus a half. It's 6x, so you times it by 6. Cos 6x, remembering the plus c, tidy that up, is minus a 12th cos 6x plus c. Now that is a difficult one, and spotting these will only come with practice, and the more questions you do, the easier it will become. So please practice plenty of these questions, and it will help you later on in this unit. But don't worry if you don't spot something straight away and have to get a little hint from exam solutions just to get you going. Right, this one we've got a double bracket, so we've got sec x plus tan x all squared. So I'm going to multiply that out. So that will give me sec squared x plus 2 sec x tan x plus tan squared x. So this stage now, I'm going to think about what, I'll just put it into here, what do I know that I can integrate and what do I need to change. So if you get your list from 11.1, you will know you can integrate that. You can integrate that. And from the first question that we did, we know that tan squared x equals sec squared x minus 1. So I've got sec squared x plus 2 sec x tan x plus sec squared x minus 1. Put those two together, I've got 2 sec squared x plus 2 sec x tan x minus 1. I've got the dx's. Notation is important in integration and you are marked on it. So now I can use my sheet from the other day. Sec squared goes to tan x. Sec x tan x goes to sec x. And minus 1 goes to minus x, so plus c. So if you've got brackets, do something with the brackets. You will get marks for multiplying it out. and then see what you can recognise. What is on the list that you can do, because you always forget about ones that are on the list and spend ages trying to. So I really would, when I'm doing the questions, have that list in front of me and all my trig identities in front of me. See if there's anything you can change. So we change that to be able to do it, and then the integration should be easy. Hope that's okay.